Welcome to the Public Exam Review for Advanced Math 3200. We will continue with Unit 5, Chapter 5 on trigonometric functions and graphs. In this presentation, we will determine the equations of sinusoidal functions given the graph. Here we will focus on developing equations of sinusoidal functions expressed in radian and degree measure from the graphs, and recognize that more than one equation can be used to represent the graph of a sinusoidal function. In the first example, which is a possible equation for the function graphed? Note that all multiple choice answers are in terms of cosine, so the first thing we need to do is identify one section of the graph that represents a cosine function. So we're looking for one cycle which would be in the shape of a V. So I'm looking at this region right here. This would be the first positive V-shaped section of the graph. So once you determine the V-shaped section of the graph, now we can look at other features of the graph. First, we can begin by looking at the equation of the sinusoidal axis, which is the x-axis itself in this case. The equation of this sinusoidal axis, it passes directly through the center of the graph, and the equation is y equals 0. You can also determine the equation of the sinusoidal axis by taking the maximum value of the function and adding the minimum value of the function and dividing by 2. So a maximum value of this function occurs when y is equal to 3, and a minimum value occurs when y is equal to a negative 3. 3 plus a negative 3, all divided by 2, is equal to 0. The equation of the sinusoidal axis tells us that the parameter d is equal to 0. In other words, there has been no vertical displacement of this new graph. We can now look at the amplitude of the function. The amplitude is given to be the distance between the sinusoidal axis and a maximum or a minimum point on your graph. So just to highlight that, the distance between the sinusoidal axis and that maximum point is 3. The distance between the sinusoidal axis and a minimum point on the graph is also equal to 3. So that tells us then that the amplitude of this function is equal to 3. It's the distance that we're looking for here. You can also use your formula to calculate the amplitude, where the amplitude is equal to the maximum value of your function minus the minimum value of the function divided by 2. So in this case, the maximum value is 3 minus a negative 3, all divided by 2, gives us 6 over 2, which is equal to 3. So that gives us the amplitude. Now we would need to look at the period of the function, which is the length for which one full cycle occurs. So if you look at the distance between a positive pi over 2 and a positive 3 pi over 2, this represents the period of the function. So the length for which one full cycle occurs here is given to be 2 pi over 2 radians, which is just equal to pi. The period of the function enables us to determine the value of the horizontal stretch. The period is equal to the horizontal stretch multiplied by 2 pi, which is the regular period of the cosine function. This period, pi, is equal to half of 2 pi. So we know then that the horizontal stretch is equal to a half. That gives us the value of the parameter b in our equation to be the reciprocal of a half, which is equal to 2. That will be the number in front of x. So now we know the values of a, which is the amplitude, we know the value of b to be 2, and we know the value of d to equal 0. The value of c is dependent upon a horizontal translation or a phase shift of this graph. In the base equation of the graph of y equals the cosine of x, it begins at the point 0, 1, when x is equal to 0. This point here that we're beginning with is located at pi over 2 and 3. So you can see that this distance right here between 0 and pi over 2 tells us that we have a vertical translation equal to pi over 2 units to the right. Now, when you look at that, that gives us the value of the parameter c in our equation to equal pi over 2. So one possible equation for this function in terms of y equals a in front of the cosine of b times x minus c plus d. So this equation would be given by a, which is your amplitude of 3, times the cosine of, the value of b is equal to 2, but you have a horizontal translation or a phase shift of pi over 2 units to the right, and then the plus 0 indicates that there's no vertical displacement. Notice that this equation is not given as one of our multiple choice answers. So that means we have to select another cycle of this graph, okay? So in this case, I chose the first positive v, which is always a good place to start, but you didn't necessarily come up with the appropriate equation that we needed. However, this here is still an acceptable equation for the graph of this sinusoidal function. So when you look at the multiple choice possibilities, the fact that the value of b here is equal to 2, that eliminates part C and D as multiple choice answers. Because in these cases, the horizontal stretch is equal to a positive 2, and our horizontal stretch is a half. So the answer has to be A or B. Notice that the absolute value of A is equal to 3, which represents the amplitude. So the answer here cannot be 3 times the cosine of 2x because we already have a horizontal translation or a phase shift. So let me select a different section of the graph to show you the correct answer. I'm going to select this section of the graph, which is again part of a V-shaped function, which represents the graph of cosine. Notice now, though, that our cosine, that the V-shaped graph is now upside down. In other words, it's been reflected in the x-axis. So because we have a vertical reflection here, that tells us that the value of A is less than 0. And as well, because the graph begins at when x is equal to 0, there is also no horizontal translation. So in this case, you could come up with another equation in terms of cosine to be y equals a negative because of the vertical reflection. 3 is the amplitude of the graph. We're dealing with the equation in terms of cosine multiplied by a horizontal stretch of a half. You use the reciprocal in the equation, and there's no horizontal translation, so we use just x by itself, or x minus 0. The correct answer that this corresponds with is A. So you are given 2 possible equations that represent the graph of this function. Let's look at another example. It says, which correctly represents the graph below? There's a maximum value of A at pi over 2 and 112, and a minimum value at B, which is located at 3 pi over 2 and 28. So the first thing we need to do is locate the equation of the sinusoidal axis. The sinusoidal axis can be determined by taking the maximum value of the function plus the minimum value divided by 2. Your maximum value is at 112. Your minimum value is at 28, all divided by 12. So here we have 140 divided by 2, and the equation of the sinusoidal axis is through y equals 70. That also gives us the value of the parameter d. So d will equal 70, and that is the equation of your sinusoidal axis. So let me just draw in that sinusoidal axis there. It's halfway between 60 and 70. I don't need a big thick line like that. So there's the equation of your sinusoidal axis through y equals 70. Now, the next thing, and notice that all 4 multiple choice answers have the value of d equal to 70 in each of the 4 cases. So next we will look at the value of the amplitude. The amplitude can be determined by taking your maximum value minus the minimum value divided by 2. So we have 112 minus 28 divided by 2. So we're looking at 84 divided by 2, which is equal to 42. That gives us the value of A to equal 42. And notice as well that we are dealing with a V-shaped graph. It's not upside down or reflected in any way. So that also tells us that there is no vertical reflection here. Therefore, the value of A will remain at 42, which is greater than 0. Again, that's indicated in all 4 multiple choice answers. So now what we need to do is determine the period of the function. The cycle begins at pi over 2, and it ends at 5 pi over 2. So you can see here that this distance between pi over 2 and 5 pi over 2 tells us that the period of this function is equal to 4 pi over 2, which is equal to 2 pi radians. That tells me that the horizontal stretch is equal to 1. We know here that the period is equal to the horizontal stretch multiplied by 2 pi, because we are using radian measure. And 2 pi is the regular period of the cosine function. So here we have 2 pi is equal to 1 multiplied by 2 pi. So in this case here, there is no horizontal stretch factor. It's just equal to 1. It remains unchanged. So then that tells us that the value of B will just equal 1. Now, the other thing that we need to look at is the starting point of the graph. So if we look here, where the graph begins at pi over 2, normally the base graph of cosine begins at 0, 1, but when x is equal to 0. However, this graph is beginning when x is equal to pi over 2. So that tells us that we have a horizontal translation equal to pi over 2 units to the right. That gives us the value for the parameter c. So c is equal to pi over 2. And now in terms of cosine, the graph y equals a times the cosine of b times x minus c plus d can be given by y represents the height is equal to a, which is your amplitude of 42, multiplied by the cosine of b is just equal to 1, so that will be given by then x, or theta is the value of x this time, or the angle is measured in terms of theta as opposed to x, minus the value of c, which is pi over 2, plus 70. So this answer then corresponds with A as the multiple choice answer. Again, there are more than one equation that can be representing this situation, but this is one example that we are looking at. In the next example, which function best represents the graph? Notice that the x-axis is labeled in radian measure, so we will use radian measure throughout our solution. We can either have the graph in terms, or the equation in terms of sine, or in terms of cosine. So let's begin by looking at the equation of the sinusoidal axis. You can see that the central line passing through this graph is passing through right about here. That's incorrect. No, it is correct, sorry. So that line there passes through y equals 3. That's the equation of your sinusoidal axis. Let's determine that by using the formula. The maximum value plus the minimum value divided by 2. So the maximum value of this function is at 5. The minimum value of the function is at 1. So 5 plus 1 divided by 2 is equal to 3. That gives us the value of the parameter d to equal 3. So when you look at the multiple choice answers, if the value of d is equal to 3, no matter if you're using sine or cosine, you can now reduce your solutions to a 50-50. We can eliminate C and D as multiple choice answers because the value of D in both of these cases is equal to a -3, and we want a +3. Let's look at the amplitude again. The amplitude can be determined by looking at the distance between the sinusoidal axis and a maximum point on the graph, or the distance between the sinusoidal axis and a minimum point on the graph. In either case there, you can see that the amplitude is equal to 2. Once again, you could determine that using the formula. The amplitude is equal to the maximum value minus the minimum value divided by 2. Your maximum value is 5. Your minimum value is 1. 5 minus 1 is 4. 4 divided by 2 is 2. And that gives us the value of A to equal 2. So the only multiple choice answers that are remaining now are in terms of sine. So what I would suggest us to do is to go pick a section of the graph that's in terms of sine. So we're now looking for a section of the graph that represents the sideways S. So the first positive section is where I always go to. So I'm looking at that section of the graph there in particular. Now, when we look at the period of the function, the length for which one full cycle occurs is between pi and 3 pi over 2. Between pi and 3 pi. So that tells us there that the period of this graph, of this function, is equal to 2 pi radians. If the period is equal to the horizontal stretch multiplied by 2 pi, we know that 2 pi equals 1 multiplied by 2 pi. So we really have just simply a horizontal stretch equal to 1, or no horizontal stretch at all. It remains the same as that of the base equation. So that tells us then that the parameter b is also equal to 1. So the only other parameter that we're looking at now is the horizontal translation. And again, I would look at the starting point for the graph. The base graph of sine begins when x is equal to 0. This graph is beginning when x is equal to pi. So that tells me that there's a horizontal translation equal to pi units to the right, which is the same as your phase shift. So that tells me that the parameter c is equal to pi. So now to come up with the final equation, or one possible equation, in terms of y equals a times the sine of b in front of x minus c plus d. We will now have y equals a to be 2, and note that your graph is going upward as it begins. So you can see there that there has been no vertical reflection. So that tells me that the value of a will remain positive. So y equals 2 times the sine of 1 times x minus pi, and that will be plus d, which is your value of your sinusoidal axis. The value of x there is given in terms of radian measure in the equation. So this answer then corresponds with A as the multiple choice solution. Let's look at another example. In this one, we will determine the equation of the function graphed in terms of sine and cosine. Notice this time that the horizontal axis is labeled in terms of degree measure. So we will come up with the equations in terms of sine and cosine using degrees. So no matter which function we're going to use, we still will have the same sinusoidal axis, the same amplitude, and the same period of the function. The only thing that changes will be the horizontal translation. So let's begin by looking at the equation of the sinusoidal axis. You take your maximum value plus the minimum value divided by 2. So your maximum value is 2. Your minimum value is a -4, all divided by 2. So we have a -2 divided by 2. The sinusoidal axis passes through y equals a -1, which gives us the value of the parameter d. So let me draw in the sinusoidal axis through y equals a -1. That's a central line that passes through the middle of your graph. Next, we will look at the amplitude. The amplitude is determined by taking the maximum value minus the minimum value divided by 2. So the maximum value is 2 minus a -4, all divided by 2. That works out to be 6/2, which is equal to 3. That gives us the parameter of A to equal 3, which is again the distance between the sinusoidal axis and a maximum or a minimum value of the function. So here you can see that the amplitude is equal to 3. Next, we will need to determine the period of the function. So now we need to pick one full cycle of our graph. So we'll begin by choosing a section of the graph that represents the sideways S, so that we will do the first equation in terms of sine. There's the first sideways S that we will choose. So now, when you look at the length for which that cycle occurs, halfway between 0 and 90 is at 45 degrees, and halfway between 180 and 270 will be 225 degrees. So now, the distance there gives us the period of the function. So the period of this graph between 45 and 225 is equal to 180 degrees. So that enables us to have to calculate the value of the horizontal stretch. So we know that the period is equal to the horizontal stretch multiplied by 360 degrees this time, because we are using degree measure as part of our solution. So now we know that 180 degrees is really equal to half of 360 degrees. So that tells us that the horizontal stretch is equal to a half, and we use the reciprocal of that to get the parameter b in our equation. So the value of b will equal 2, and that represents one full cycle of the curve. The period here is equal to 180 degrees. So now we'll first of all come up with the equation in terms of sine. So we're looking at y equals a multiplied by the sine of b times x minus c plus d. The values of a, b, and d will remain the same no matter which function we will write the equation in terms of. So the first thing we need to determine is when you look at the shape of the sideways S, notice that the function is increasing as we begin. So that tells us that there has been no vertical reflections. There's no vertical reflection. The shape of the graph is going as it should be. So that tells us that the value of A is positive. A is greater than 0. Normally, the sine function begins when x is equal to 0. However, in this section of the graph, it begins when x is equal to 45 degrees. So here we have a horizontal translation or a phase shift equal to 45 degrees to the right. So now we can write the equation of this function as y equals 3 multiplied by the sine of 2 times x minus 45 plus the value of d, which is equal to a -1. So we just say -1 at the end. And that will give us one equation that represents the graph of this function in terms of sine. So now let's look at another equation in terms of cosine. So now we will look at y equals a times the cosine of b times x minus c plus d. Now, in order to get the equation of the cosine function, we need to pick a section of the graph that represents a V-shaped section. Now, there are several here that you can choose from because we can have an infinite number of equations that represents this situation. So if I chose an upside down V, right here, I would have to deal with a vertical reflection. So let's take the section that represents the first positive V. So this is a section that I'm still looking at. Notice that the period did not change. The distance between 90 degrees and 270 degrees is still 180 degrees. So the period of the function is 180, the horizontal stretch is a half, and the value of b is still going to equal 2. The amplitude is still the same. The distance between the sinusoidal axis and a maximum or a minimum point on the graph is still equal to 3 units. And the central line that passes through the graph still occurs at y equals a -1. So the only thing that it does change is the parameter c. Normally the graph of cosine begins at 0, 1, but this graph begins at 90 and 2. So here we have, again, the V is in the right shape, so there is no vertical reflection. But we do have a horizontal translation equal to 90 degrees to the right. So one possible equation here would be y equals 3 multiplied by the cosine of 2 times x minus 90 minus 1. And that gives us another equation of the same graph. If I had to do one, I'd just like to include another one here in terms of cosine probably. If I had to take the section of the graph, and let me highlight it for you, we'll use the color green here. If I had to take this section of the graph, note that the distance between 0 and 180 still confirms that the graph has a period of 180 degrees. So the period in the horizontal stretch is still going to be a half. The amplitude is going to be 3. The sinusoidal axis is still through y equals a -1. But in terms of the cosine this time, note that your graph, this time, the V is upside down. So here we did have a vertical reflection in the x-axis. A vertical reflection in the x-axis. That tells us that the value of A must be negative. It must be less than 0. And this time, the graph is starting when x is equal to 0 because it begins at 0, -4. So this time you had no horizontal translation. So that tells us that the value of c would equal 0. So now we could come up with another equation that represents the same graph. Here it is. Y equals the negative because of the vertical reflection in the x-axis. 3 is still going to be your amplitude. The cosine of, it's going to be a horizontal stretch of a half, puts a 2 in front of the x. There is no horizontal translation, so it's x minus 0, and then -1 at the end. So this is another equation in terms of cosine. All 3 equations, and like I said, there are an infinite number of possibilities that you could use here, depending upon which section of the graph that you choose to represent sine or cosine. Let's do one more example in terms of radian measure. So we'll come up with the equations again in terms of sine and cosine. The equation of the sinusoidal axis, equals the maximum value plus the minimum value divided by 2. The maximum value of your function occurs here when y is equal to 4. Your minimum value occurs when y is 0 divided by 2. 4 over 2 is just 2. So your sinusoidal axis will pass through y equals 2, and the parameter d is equal to 2. So let me just draw in the equation, or the horizontal line that passes through the center of your graph, through y equals 2. Next we can look at the amplitude, and you can already see that the distance between a maximum or a minimum value of the function gives us the amplitude of your graph. The amplitude is equal to 2, but if you need to use the formula, go ahead. Maximum minus the minimum divided by 2. So we have 4 minus 0 divided by 2. The amplitude here is equal to 2. So that tells us that the parameter A is also equal to 2. Now we need to look at one full cycle of the graph. So if I were to determine the length for which one full cycle occurs, I'm first of all going to pick a section of the graph. Let's go between, the easiest one to pick would be between 0 and 2 pi over 3. That's a V-shaped section of the graph, even though it is reflected. But you can see there that that distance gives us the period of the function. So the period here is equal to 2 pi over 3 radians. That will enable us to determine the horizontal stretch. If the period is equal to the horizontal stretch multiplied by 2 pi, which is the period, the regular period of the base graph of sine or cosine in radian measure. So here you have 2 pi over 3 is equal to the horizontal stretch multiplied by 2 pi. So you can see there that 2 pi over 3 is equal to 1/3 multiplied by 2 pi. So that tells us then that we've got a horizontal stretch equal to 1/3, and that means that the parameter B is going to equal 3. Now we will determine the equation in terms, in terms of sine or cosine. So I'm going to stick with the same section of the graph that I just chose. Okay, so I'm looking at this the V-shaped graph that has been reflected. So let's look at that section first. So the first equation that we will come up with will be in terms of cosine. So it's A times the cosine of B outside of x minus c plus d. Note that you had a vertical reflection in that section of the graph. A vertical reflection in the x-axis. So that tells me that the value of A must be less than 0. And there is also no horizontal translation in this case. The normal graph of cosine begins when x is equal to 0, and this is also true for this graph of this function. It begins when x is equal to 0. So the equation then would be given by y equals a negative because of the vertical reflection. Your amplitude is equal to 2 multiplied by the cosine of, the value of b is equal to 3 because we have a horizontal stretch of 1/3. There's no horizontal translation, so it's just x minus 0 or just x, and the value of d is equal to 2. So you have a plus 2 at the end. So that's one equation in terms of cosine. The next equation that we need to come up with has to be in terms of sine. So we're looking at y equals A times the sine of B times x minus c plus d. So now let's go pick a sideways S shape of the graph. So it will begin here at the sinusoidal axis and I'm going to take this section right here. Note that the distance between, halfway between 0 and pi over 3 is going to be pi over 6 units. So it'd be from pi over 6 to 5 pi over 6. The distance is still going to be 2 pi over 3 units. Okay, still going to be 2 pi over 3 units. So the period of that function does not change. Note that we do not have, oopsie daisy, that's too big there. Let me fix my pen. So here we have no vertical reflections, right? Because my graph is starting off by increasing. So you got the regular shape there. There's no vertical reflection. Therefore, the value of A will be positive. A has to be greater than 0. However, we do have a phase shift. There is a horizontal translation. And like I said, halfway between 0 and pi over 3 is pi over 6 units. So we have a horizontal translation of pi over 6 units to the right, which gives us the value of the parameter C to be pi over 6. So this equation then would be given by y equals 2 multiplied by the sine of the value of 3 times x minus pi over 6 because of your horizontal translation, and the value of d is equal to 2. So we add 2 at the end. And this is another equation that we can use in terms of sine. As a summary then of what we have completed in this presentation, what I recommend is that you select one full cycle of the graph in terms of sine or cosine. If you're looking at the shape of the graph in terms of in terms of sine, you're looking for an S-shaped graph, like that. This will be the one involving sine. If you're looking for the cosine graph, it's in the shape of a V for cosine. So that's the two shapes, or the section of the cycle, or one full cycle that you should look for. Then you could determine the equation of the sinusoidal axis. This represents the vertical displacement, which corresponds with the parameter d. It also represents a vertical, it can also be referred to as a vertical translation. The formula used to calculate the equation of the sinusoidal axis is the maximum plus the minimum values of the function divided by 2. Next, we determine the amplitude of the function, which represents the vertical stretch. That corresponds to the parameter A, using the formula where amplitude is equal to the maximum value minus the minimum value divided by 2. Next, you determine the period of the function, which is the length for which one full cycle occurs. This affects the horizontal stretch, where the period is equal to the horizontal stretch multiplied by 360 if you are using degree measure, or the period is equal to the horizontal stretch multiplied by 2 pi if you're using radian measure. And whatever the horizontal stretch is, the value of B is the reciprocal of that. So B is the reciprocal of the horizontal stretch. You determine if any horizontal translations occur, which affects the parameter C, and this also represents the phase shift. Determine if any reflections occur. If there's a reflection in the x-axis, then the value of A will be less than 0. If there is a horizontal reflection in the y-axis, then the value of B will be less than 0. And then you can write your equation in terms of y equals A times the cosine or sine of B times x minus C plus D. Thank you.